ID number must be 13 characters long. Once users entered all the details, they're able to click register. The first name must not contain a character, a number, as well as the surname. The email must contain an @ will not be saved. The password and username must contain at least one capital letter and a number. Once the user successfully registers, it takes them to the customer login page. I will now be demonstrating how the customer login feature works, and I'll be using the data that was inputted in the customer register page. First, the user must enter their username and their password, but if their password is incorrect, it will display an error, such as invalid username or password. Same with the username. So if the password is correct, and then the username is incorrect, it will display an error, the same error. So now, if both inputs are correct, it will then log the user into the customer dashboard or into the application. My name is Aiden, and I'll be demonstrating the register and login functions of our banking portal. So how the register works is that when the data is inputted, it validates each input, such as the first name, email, username, and ID number. If any of the validations or any of the inputs are incorrectly formatted, it displays an error to the user. And then once the inputs pass the validation, a random account number is generated. A SALT is created with B. My name is Aiden, and I'll now be talking about the backend for the login. To ensure that our login is secure, we have implemented Express Brute. Express Brute limits the amount of times a user can attempt to log in. So after a certain amount of inputs by a user or attempts to log in, the user will be blocked. How the login functions is first, the database checks for a user with a given username. If the user is not found, it responds with an invalid username or password. If the user is found, it compares the entered password with the password that is connected to the user that has been found in the database. If they do not match, the user is then displayed with an error that says invalid username or password. Once the username and password has been correctly inputted and there's no errors, the login then generates a token for the user.
Hi, my name is Mikayle Turner. Upon logging in, the user will be greeted by the dashboard. Here, the username is displayed. In this case, it's Mike Taylor. The user can also click one of the buttons to make either a local payment or an international payment. User bank details such as their account type, account number, and available balance will be displayed here. One of our extra features is this card. You can see the Swift banking card, the account type, the name of the account holder, the account number, and its available balance on this card. Below the card, you can see the payment receipts. Here, you can see all the payments that the user has made, as well as the history of them, such as the date, the recipient name, recipient bank, amount, SWIFT code, and transaction status. This will allow the user to keep track and manage their transactions. On the left, you can see the menu bar. Here, the user can use the menu bar to navigate to the various points within the app, such as transactions, local payments, deposit, and international payments. When the user navigates to the transactions, they will see their transaction history. This will display in the format of a table. including the date, recipient name, recipient bank, amount, and SWIFT code. To make a transaction, the user must first add funds. When the user adds funds, they act like a deposit. The deposit will allow the user to add funds to their account in case that they can't reach an ATM. This is for test purposes, as in reality, this would be a big disadvantage to allow users to enter funds like this, but this is necessary for our testing. And to be able to simulate payments properly, the users must have an amount in their bank. Payments can be made by either clicking Make a Local Payment or Make an International Payment. Once one is clicked, the user must enter the details. If the details are entered incorrectly, or if the details are invalid, the user will not be able to proceed and click pay when they pay now. If the user wishes to, they can click Cancel at any time to return to the dashboard. The user must enter a recipient name, recipient bank, which are not checked, as this will be checked by employees, as well as be checked when connected to the SWIFT network. Without access to the SWIFT network, the users would not be able to make interbank trades or exchanges. So therefore, this is a necessary part and would need access to the other banks on the SWIFT banking pipeline. Furthermore, when the user sets the amount to transfer and enters and clicks Pay Now, the amount is deducted from their bank account and the transaction is then pending. This means that it is waiting confirmation from a banking employee. You can see that inside the database, the various transactions, as well as the users, along with their correlating IDs, are all stored. It is very important that when users are stored and accounts are stored, that they are correlated using the user ID. The account number is also correlated here.
Hi, my name is Aiden and I'll be explaining how the admin creation works from Postman. So first, you need to log in with an admin account that has the admin role because you need the authorization to create an admin account. So first I'm going to log in. I'm then going to grab the token from the account, copy, go to the post create admin, authorization, bearer token, copy and paste the bearer token, then go to body, then copy and paste my dummy data from my admin account, copy and paste, and there we go. The admin account is created and has the role admin, which then allows it to do admin activities and access the admin dashboard. I will now be showing how the admin creation works in the front end. So first, they log in. You then grab the user. You enter in your admin details. So username, password, logged in. Then it displays with an admin dashboard. Then this admin is able to look at all the users in the database, all the other admins, and the employees. To create an admin in the front end, you go here. You get your dummy data. So first name, Johnson, last name, White, email address, copy and paste, admin89, the username, then the password, and then lastly, the ID. And then the admin account is created. So I can go here, look at admins, and then Johnson White is here. So this is how you create an admin from the front end as an admin with the admin role.
And I'm going to be showing you how to create an employee. We're going to first start by logging in. Let's start by entering an admin's details, as an employee cannot be created by another employee. Employees can only be created by admins. So we can log in here and we can view all our employees. We'll do an example of deleting an employee. Let's delete Guy Ellis. We'll remove him and you'll see he is no longer in the database and has been removed from our database. We will then go into the users and let's give an example of deleting a user. The user is now removed and no longer is in the database. So let's go on ahead and create an employee. We'll create an employee by entering the employee details. Let's create a new Guy Ellis and we'll give him a valid email and we'll give him a new username. We will then enter in a valid password and we'll give him a valid ID. Sorry, that employee ID was of the wrong length. Finally, now we have a new user, a new employee that we can now see in our database and log in as. So let's say, for example, we want to log in as Guy Ellis. Let's log out and log in. We'll go Guy at Swift. And we'll log in and you can see that this is a new employee account created from an admin account. And he can do likewise many of the same things general employees can do.
Hi, my name's Aiden and I'll be explaining each role. So there are only 3 roles: admin, employee, and customer. User. User is the average customer. They are only able to access these on the dashboard. Transactions, local payments, deposit, and international payments. They are also the only role to be displayed with this front end, and they're also displayed with customer dashboard. The second role is employee. Employees only have access to transaction management, where they're able to flag and confirm payments. The employee schema account does not have a balance or account number like the user, which is a customer role. The last role is admin, and they are able to access everything, such as transactions, admin creation, and create employee. They're also able to view every single type of user in the database, and they're also able to delete users. They're also the only role to be able to able to create admins and employees.
Here is an example of an employee logging in. They log in through the same portal as the customers, and the admins will also log in through the same login portal. We click login, and if the employee details are correct, they can enter the transaction management page. This is all that the employee will need in one page. An employee can confirm or deny transactions, and it will update the status along the status column there. They can filter between confirmed and denied transactions, and they can also further flag transactions. They can view all the flagged transactions. Flagged transactions are a bonus feature of our project, and it will allow transactions to be raised to higher authorities to observe and monitor transactions. This is something that's used in banking systems often, and we thought was a worthwhile addition to the project and showed extra effort. Once flagged, the transaction can then be confirmed or denied, and all transactions are shown. You can see the transactions history. If we were to log out and log in as a customer, say Jane Doe. We can make a new local payment. We'll say Mrs. Baker. And we'll pay her 2,000 rands, and we'll enter a SWIFT code. Now you can see that the transaction is updated. The money has been subtracted from her account, and then when we log out and we log back in as the employee, we can see Mrs. Baker's pending transaction over here, which we can now confirm, and it continues as normal.
Hello everyone, my name is Mikayle. Today I will walk you through the CI/CD pipeline configuration for our React project using GitHub Actions. This pipeline automates building, testing, and securing the project to ensure everything runs smoothly before deployment. The pipeline has two trigger events, one of them for when the code is pushed to the main and the other for when the main branch is pulled. This ensures that every change is made to the main branch, whether directly or through a pull request, is automatically tested and built. Next, in the job section, we define a single job called build. This job will run on the Ubuntu latest environment, which provides a clean virtual machine for every pipeline execution. Within the service block, I also started MongoDB instance version 4.4 because the project requires a database. The service is mapped on port 27017, so it can be accessed during the pipeline run. For the Node.js section, I've set up a matrix with two node versions, 16 and 18. This ensures that the project is built and tested in both environments, giving us confidence that the project can work across different versions and Node.js. So let's go through the steps of the pipeline. First, we use action checkout to clone the repository into the runner's workspace to ensure that the latest code is available for all steps. Next, we use action setup node to install Node.js version 18, which is required for the project. Then I navigate to the backend directory and run npm install and install all backend dependencies. After that, we fix the permissions for the node modules folder, especially necessary when working with Linux-based systems like Ubuntu. At step 5, I make sure that the React scripts binary has the necessary execution permissions. This is to avoid any permission errors while running scripts. After that, we installed front-end dependencies. The legacy peer deps flag is used to ensure compatibility with older dependencies in the project. And just to be safe, I explicitly installed React scripts with npm install React script legacy dependencies in case it wasn't installed earlier. At step 8, we then check whether the SSL certificates are present in the backend. If the SSL certificate or key is missing, the pipeline will fail, ensuring secure HTTPS connections. For step 9, we installed HTTPy, a command line tool for making API requests, which is useful for testing the backend. Next, we started the backend server in the background and waited 5 seconds to ensure that it is up before proceeding. This allowed the server to be available for tests and further checks. For step 11, I ran various security checks in the backend. We check for Helmet's frame guard middleware to protect against click tracking attacks. We look for session management libraries like cookie sessions and express sessions. This checks the parameterized queries in the database layer to prevent SQL injection. We verify the HTTP strict transport security is enforced using Helmet. Finally, I check if the express rate limit middleware to prevent DDoS attacks by limiting request rates. Lastly, if the pipeline encounters any failures, I upload the test results. This helps with debugging by preserving logs and error details. In our project, we also make use of Circle CI. It plays a critical role in automating the entire process for continuous integration and delivery. Every time that we make a change in the codebase and push the code to the repository, Circle CI will automatically trigger a series of actions to build and test the code. This ensures that each commit is thoroughly tested in a consistent environment, reducing the risk of introducing bugs or conflicts. As you can see, our pipeline did pass, and this means that our code passes both functional tests and static examinations before being merged. The platform's ability to handle parallel testing and deployment processes means that it can quickly identify any failures or issues in our code. Additionally, Circle CI provides real-time feedback about the build and test results, allowing us to respond rapidly to any problems. So, by automating these testing and development tasks, Circle CI improves our development cycle's efficiency, reduces manual interventions, and helps us maintain a stable and reliable codebase. It provides a robust infrastructure for the entire team to rely on, ensuring that only properly tested code reaches production. We also integrated Sonar Cloud to perform static code analysis and ensure high-quality code. Sonar Cloud scans the code for bugs, vulnerabilities, and code smells, giving immediate feedback about areas that needs to be improved. While Circle CI takes care of building and testing the code, Sonar Code focuses on analyzing the quality of the code itself, ensuring that the code follows the best practices for readability, maintainability, and security. Sonar Cloud evaluates key metrics like code coverage, duplicates, and potential security vulnerabilities. It provides us with actionable insight to fix any issues before they escalate, helping us maintain a clean, efficient code base. By integrating Sonar Cloud into the pipeline, we ensure that code's quality is maintained consistently, complementing Circle CI's functionality in testing and any additional layers of quality assurance. So with Sonar Cloud, we can confidently assess the state of our code, quickly address any issues that arise, and ensure that the code is not only functional, but also high quality.